Welcome to Tech Lab by Sid. In this video, we will discuss about vector database. Imagine asking AI, what are good family cars? But the documents only contain words like SUV, automobile, vehicle, sedan. No document actually contains the word car. A traditional database might fail. But modern AI somehow still finds the correct information. How? The answer is something called a vector database. And today we are going to understand exactly how AI searches billions of pieces of information in milliseconds. Why traditional databases struggle? Traditional databases are amazing. They store customer records, orders, products, transactions, and they retrieve data using exact matches. For example, find customer ID 101, find order number 5001, find product name laptop. But AI questions are different. AI often searches by meaning, not exact words. And that's where traditional databases become limited. As we learned in our embeddings video, AI converts words into numbers. These numbers are called vectors. And similar meanings produce similar vectors. Car, vehicle, automobile, SUV, all end up close together in mathematical space. This ability to represent meaning numerically makes semantic search possible. What is a vector? A vector is simply a list of numbers. For example, car might become 0.82, 0.12 minus 0, 44, and hundreds of other numbers. Modern embeddings often contain hundreds or even thousands of dimensions. These dimensions capture meaning. The numbers themselves are not important. What matters is how close one vector is to another. The similarity problem. Imagine billions of vectors floating in space. Some are close together. Some are far apart. The challenge becomes, when a user asks a question, how do we find the nearest vectors among billions of possibilities? This is the problem vector databases were created to solve. What is a vector database? A vector database is not a normal database. Instead of storing only rows and columns, it stores vectors. And more importantly, it is optimized to search similar vectors extremely quickly. Think of it as Google Maps for meaning. It knows where every vector lies. And it can instantly find nearby concepts. How data gets stored? The process usually looks like this. Step 1. Take documents. Step 2. Generate embeddings. Step 3. Store embeddings inside a vector database. Every document now has a mathematical location, which means AI can search by meaning instead of keywords. When you ask, what are good family cars? The question also becomes a vector. The database then asks, which stored vectors are closest to this new vector? This process is called similarity search. Imagine dropping a pin on Google Maps. The database immediately finds the nearest restaurants. Vector databases do exactly the same thing. Except instead of restaurants, they find nearby meanings. This process is called nearest neighbor search. Why speed matters? Searching billions of vectors one by one would be extremely slow. So vector databases use special algorithms called Approximate Nearest Neighbor Search, or ANN. Instead of checking every vector, The database intelligently narrows the search. The result: milliseconds of search time, even across billions of embeddings. Why RAG needs vector databases? Without vector databases, modern RAG systems would barely work. RAG needs to find relevant documents by meaning. That retrieval happens inside a vector database. This is why embeddings, vector databases, and RAG always work together. AI agents also use vector databases because agents need memory. They need to remember conversations, user preferences, previous tasks, knowledge. All of this can be stored as embeddings, making vector databases the memory layer of modern AI systems. Today, vector databases power ChatGPT memory, RAG systems, recommendation engines, search engines, fraud detection, customer support, healthcare AI, enterprise knowledge systems, and intelligent agents. You are already using vector databases every day. You just don't realize it. Some popular vector databases are Pinecone, Weaviate, Milvus, Chroma, Qdrant, PageVector. Each has different strengths, but they all solve the same problem: fast semantic retrieval. Traditional databases answer, what exactly matches this value? Vector databases answer, what means the same thing? That one difference changed AI forever. Embeddings create meaning. Vector databases store meaning. RAG retrieves meaning. And AI agents remember meaning. This is why vector databases have become one of the foundational technologies behind modern generative AI. And now you've learned how AI searches not by words, but by meaning itself. Thanks for watching the video. Be sure to explore our channel for more content like this.